today we might have a guest who partly makes up for the fact that we're missing those meetings. And that's because we are talking to the Tony Stark of the audio world. If you don't know who Tony Stark is, he's the man in Iron Man, and he developed a very sophisticated product in that movie from a beginning point that was not as high tech as you might think. And maybe that's somewhat similar, but he also happens to be a very ingenious guy, and I think that's also similar to our guest today, who is none other than Richard Vandersteen, a man who in his past has been nothing less than a construction worker, a contractor, a plumber, a truck driver, an electrician, and a specialist in electronics and ground-to-air communications in the Air Force. We're here today with Richard, and we are very, very glad to introduce him to all of you. Well, I'm just going to start with the origin story, as they call it in those movies, and ask you, Richard, way back when you first decided that you wanted to design a speaker, can you tell us what you were doing at that time and how that idea came to you?
Well, going back to a kid, my parents, they immigrated from the Netherlands, and Dad was always into music. We did not have a television in the home, but we did have a record player. In fact, his record player would also cut its own records, and we would cut records with the kids' voices and everything and send it back to the family in the Netherlands. And that's how they communicated back then. So, of course, it had a speaker in it, and I was always trying to make it sound better, and built a tube amp for it, I don't know, 10 years old or so that it would sound better. And so it was always an interest of mine. But actually, at the time, I was driving truck for a living, which is a way to make a living and still have nothing to do but time to think, and was just as a hobbyist playing around with it in the garage. And a place called Lafayette at the time, and Allied was a good source of some pretty good parts, and yeah, that's it grew out of that.
And what intrigued you at the beginning that made you think, I think I should design a speaker?
Well, the first speaker was actually a big box with a lot of drivers in it. If people would see, and we did sell a fair amount of them. Most of them went into discos, but if people would see that first speaker, they would, no, that couldn't be a Vandersteen, because it broke every rule of what we ended up doing and bringing to the market commercially. It broke every rule that we have and still have to this day. That has been true to our basic design for over 40, now almost 45 years. But it was a big box with lots of woofers, mid-ranges, and tweeters in it, and would play very loud. And that was the beginning. And there was a high-end store called California Audio that opened in Visalia. And one day on a Saturday, had nothing to do. I dropped by there, and was every retailer's nightmare. Some kid walking in saying, "Hey, I make speakers. You want to hear them?" And they humored me. They said, "Yeah, bring them on by." So on a Thursday, we did, and they thought they were really interesting. And I knew nothing about the industry at that time. I wasn't really into the hobby. I was just kind of in my own world, playing with this stuff. And yeah, that was the beginning. Then basically decided that maybe this would be a way to make a living. And they did the marketing for us, said, "Hey, there's such a thing as CES shows." So we went to CES in Chicago in 1977. But before that happened, they were talking about East Coast sound, West Coast sound, and I was so discouraged because I'd already kind of convinced my new wife at the time that I'd like to make a living making loudspeakers, but the marketing people couldn't decide on what sound we should make. And I was really pretty demoralized by that, and had a thought driving truck one day, why don't we try to make a speaker that has as little sound as possible, that tries to recreate what comes from the amplifier. So Thursday night, went there and made my proposal. I think we ought to. So Nevin at the time had a Revox tape deck and some kind of ribbon microphones, I don't remember, whatever, and we started recording instruments and playing it back through different prototypes. And the next thing we know, we were down to one tweeter and we were down to one mid-range, and it was on a pole, and the steep filters went away, and more than one driver at the higher frequency smeared each other. So we were down to one, and then we aligned it, and then but if you aligned them and you wanted to really pass a pulse, it had to be first order. After about a year of that, they said, "Hey, let's go to the show. Let's see what we got." I was still working, and we borrowed a blue van, drove across the country, and showed them in Chicago, and ended up with a lot of dealers and way too many orders. I was knocking out a pair of these a week in the garage, and that was the beginning of Vandersteen Audio.
That's
those basic principles that we discovered, those basic principles and guidelines, the minimum baffle, the one driver per frequency range, first order filters, are still what everything is based on that I make today. Those basic, all of those basic things are still what gets me most emotionally involved in music on the master tapes of things that I've recorded myself. So one of the difficulties is when you use recordings, you never really know what it sounded like when it was made. So early into this, got into make our own recordings to where we would have references, to where we would know what it was supposed to sound. And it involves scraping shovels on concrete, pounding cardboard boxes. You wouldn't believe piano, of course, guitar, human voice. It was kind of crazy, but it was also a lot of fun and a time to drink plenty of beer too. So whatever. That's how it happened.
That's a great story. That's really intense. You were making your own music, but also your own sounds to see what the speaker could do.
Well, we didn't make a lot of music. They were mostly sounds. And of course, the instruments that people played, that was, but yeah, just trying to recreate and I tend to hear things the way I think they should because of what I've engineered into it. So I've never really done my own evaluations. I've always relied on panels and other people to keep me centered, because it's hard to remain objective when you're that involved in what's going on. So had the help of a lot of people, stood on the shoulders of a lot of tall people.
And it sounds like your design principles didn't come from some religious belief after reading a text, but came from the results of your real world tests.
Yeah, but I wasn't, partly because I was not aware of what my parents, it was all homemade stuff. So I was unaware of what was going on in the industry at the time. I didn't know what traditional loudspeaker design was. I was just not, it was not an area of interest to me. I don't like doing something that other people have done before. There's a lot of people that do that very successfully. I try to find better solutions and unique solutions. So I tend to keep myself blinded from what tradition. It's really not very interesting to me to know what someone else has done.
Yeah, that's cool. And part of the story, I want to just go back to what you said. You talked about first order crossover. Translation to a guy like me who doesn't build speakers is that's basically the most gentle kind of crossover you can apply. Is that a fair summary?
It is very difficult to do. They're not easy, but in their simplest form, they are the easiest. It does put a lot of demand on the drivers. You have to have better than normal drivers because their range of operation must be larger. It pretty much eliminates the whole idea of doing a real expensive two-way, because the distortion and drivers with that many octaves of good low distortion range, pistonic action, whatever motion, whatever you want to call it, are just not possible. So at a pretty moderate price, you're into at least a 3 or a 4-way in order to make it work. But yes, they are gentle roll-offs because first order filters are the only filters that have at least the opportunity to be time and phase correct. Doesn't guarantee it, but they have to be there in order to even have a chance of being time and phase correct.
And I want to ask you about time and phase correctness, but first I want to go back to one more thing you said in the origin story, which was you talked about getting the number of drivers right for each frequency range, other physical aspects, but then you said one of the things we tried was we aligned it. Can you tell us what really was involved with, what does that mean?
Well, shortly into that endeavor, we would have to use a scope and put in square waves. But if you divided the spectrum into 3 ranges, a woofer, a mid-range, and a tweeter, and you want those 3 to sum in flat frequency response, but you also want them to sum in a way where a transient, basically a step function, would add up to a square wave seen by the microphone, fed into an oscilloscope as a square wave again. In order to construct it to back to what it started out at, they had to be aligned. You can't do that electronically unless you get involved with digital delays. But this is way before digital. We didn't have those but there was a thing called bucket brigades in the day that could do that. But they were very complex, and it took a lot of them to get that much time delay in order to align a tweeter, a mid-range, and a woofer.
So you're talking about making the drivers physically in space so that they are projecting things in a time-aligned way.
Yeah, so that, and you're not just lining up the voice coils, because it has to do with the speed of the driver. It has to do with the shape of the diaphragm, of course. The location of the voice coil is part of it. But basically what you're looking for at the listening position, or wherever you put the measurement microphone, is for everything to add up the way it was before you broke it down into 3 separate pieces.
And when you say phase correct, can you give us a kind of a user-friendly summary of what that is?
In its simplest form, it would mean that all drivers are in positive phase, so that if an instrument would make a transient, that all of its harmonics and all of its overtones and everything would be acoustically, that could involve at least 2, sometimes 3 drivers. But you want all of those harmonics to be acoustically, if they started out as a positive pressure wave in the room to impact your eardrum so that we can hear it, we want all of those to be in positive phase then. And the simple way to do that is to just make sure that if you put a square wave in, that these 3, and then divide it up into these 3 different spectrums, but then have them come back together at the listening position, at the microphone, so that you can not only reconstruct the frequency response, which is relatively easy. You can even do that by putting a mid-range out of phase. And 98% of the speakers in the market are that way for legitimate reasons. But I'm trying to get all of the harmonics and the overtones on a particular instrument to be a pressure wave in the room impacting our eardrums as if that instrument was actually in that room. And it's interesting, cartridges are time and phase correct, wires are time and phase correct, obviously. Preamps and amplifiers are, microphones are, they might roll off the top and the bottom a little bit, but they're basically time and phase correct. It's only when we get to the loudspeaker, the industry's been very tolerant of things going every which direction. So focusing primarily on the amplitude response. As human beings, our ear-brain combination is actually less sensitive to amplitude or frequency response deviations than it is timing issues. This is how we echolocate. This is how we know where sounds come from. These are differences in timing between our two ears that the brain interpolates as a third dimension, or where we are or where that sound was located in space.
That makes a lot of sense for me, because I've always wondered why all of your speakers have a certain appeal to me, which I don't expect to find at the lower price ranges. In other companies, the lower priced speakers to me just leave me cold, and yours don't. And I'm a drummer, so I'm all about timing. It's the most important thing to me. And I don't hear people talk about it enough. You can read 10 reviews of different audio components and they won't mention timing or rhythm once.
It's because it's probably not the most important parameter in designing a loudspeaker. Being reasonably low in distortion, not having your drivers bottom, not having your woofers double, being reasonably flat in amplitude response, which is tonality, not being too far off in tonality to where you start making everything sound like a kazoo. That's obvious. The whole timing thing is a learned experience. It has to do with it's not an impressive thing. It's people ask me, well, how do you know when something's really wrong? I says, well, if your impression when you hear something new is, wow, I've never quite heard it like that before, that's probably a pretty good indication there's something interesting but pretty seriously wrong. The funny thing is, when males especially go out to buy stuff like subwoofers and speakers, we want to be impressed. We want that subwoofer to thump and bump and dance on the floor and everything, because we're talking about spending a lot of money. Once we own it though and put it in our system, we want it to blend into the music and not make itself so evident that it's reproduced sound versus real music. So the whole timing thing is a learned response. It's not the first thing that you learn about evaluating loudspeakers, or even finding which loudspeaker is going to be your best choice for your own personal taste. And then there are a lot of people in our hobby, when you look at all the different loudspeakers that are available, that are looking for an experience that's different than trying to recreate or trying to bring those instruments into the room. There are two kinds of recordings. Studio jobs are trying to put that performance in your living room, and live performances or symphonic works are trying to transport you to the venue. So you bring the venue into your home, or you bring yourself to the venue. But those are the two different recording styles. And not everybody is seeking to have that happen as accurately as possible. Many are seeking an experience that's related to music, obviously, but a totally different experience than which I don't fully understand. But when I go about the shows, listening to all the different products out there, I'm going, wow, that doesn't really even sound like a cover of that person. That's interesting, but people must like it because they're in business and somebody's buying them. But it's just not for me. I'm not saying it's wrong. It's just not. It just wasn't. I have a severe analytical mind. For me to get moved into my emotional part of my brain, I told John Atkinson in an interview one time, I said the only thing that does that is a time and phase correct, decent recording of good music, and my wife naked. If it doesn't, if the music, if it doesn't emotionally engage me, it doesn't work. I move on to something else. People who have a lot of artistic content and have developed that part of their brain, they have this unique ability that I don't have any of, and they can just fill in the blanks. Musicians do that all the time. They can be bombing down the road in their car with the convertible top down and the radio blasting, a stock radio, not a very good one, and really get off on the music. And the reason for that is their brain is filling in all the blanks. But that doesn't work for me. And that's part of the reason why our product is what it is, because it has to work or I turn it off.
And it really does make an impression on a guy like me when every speaker in the line kind of gives me what I want. So
well, they're all based on the same. They're all based on the same criteria,
right?
At different price points, of course.
By the way, for the viewers, if you have a question, you can go to the little go to webinar box and click on the gray stripe that says chat, and you should be able to see a chat window pop down. If you type in a question there, either I'll see it or Aaron will make me see it, which is good, and we want that. Let me ask you, and this is a little bit related to what we just talked about, what are the failings that you hear the most often in audiophile speakers from other manufacturers? You don't have to name names if you don't want to, although it would be very juicy and dramatic if you did. But what do you hear that sticks out like a sore thumb when you're listening to other brands?
You design these things and you build them and then you put them on the market and you have to sell them to stay in business. And a lot of speaker manufacturers are a lot more in tune with how you get a guy's attention. And probably what assaults me the most when I hear a lot of different speaker designs is them being excessively bright, which is done to get attention, to sound really hi-fi. And you can see even in stereophiles measurements that many of them are excessively bright. But basically that's to call attention to themselves and hopefully hold on to the customer till the check clears. But to me, we have enough recordings that are kind of iffy in the way they are made anyway. That's like pouring salt into the wound. So that's probably what I hear when I go around. Now ours are not rolled off. They measure absolutely flat at the source, which means at the listening position, because you have more, as energy travels through space, it's a wavelength. There's attenuation. And obviously between your speakers and your ears and your listening chair, there are going to be more events in the high frequency, more wavelengths, more waves in the high frequency than there were in the low. And this causes about a 4.5 dB tilt at the listening position, where your tweeter, if the speaker truly is anechoically flat, at 1 meter or at the source, it's going to measure about 4.5 dB down at 20K at the listening position. But that doesn't mean the speaker's rolled off. The speaker is absolutely flat. It's putting everything into the room that it's supposed to be. A lot of speakers out there will actually measure flat at the listening position. And you can do that with a piano. You can look at the spectrum of a piano and hit a key 1 meter away from the piano, and then go 3 or 4 meters away from the piano and hit the same key. And you'll see this same downward slope because the high frequencies are absorbed more so than the lows. That's a natural thing. It occurs in nature. It's superimposed on everything we listen to.
It certainly comes through. When I listen to the various models that you offer, there is just a natural sense, or a sense of ease that is not hyped. And so I hear what you're saying. Getting on to your process of building speakers, can you tell us a couple of things that we may not appreciate in terms of the efforts that you go to in building? Take any pair of, whether it's your bookshelves or your 9 series. What is something that you're doing that we're just not seeing?
Well, there's a lot that goes on behind the scenes to make a time and phase correct loudspeaker. I think the one thing that is unknown to most, although we have a video now on our website on where we show a trio being built from raw material to finished, and because all our stuff is based on the same stuff, you get a pretty good overview. But if you're going to do a time and phase correct loudspeaker, every single pair has to have its crossover dialed in to that particular pair within an anechoic chamber. Now, this is not new. John Dunleavy did that in the day when he was alive in the Duntech speakers and Dunleavy speakers. John Bow used to do that with even the Spica TC50. That's why there were codes on which particular tweeter had to go in for replacement. The amount of care, it's not like you design it by 1% parts, build 100 of them and test every 10th one to make sure they're going together right. No, every pair has to go into the chamber, and my son Nathan is the one that does that work. A lot of people are not aware of the attention to detail there. Now, the neat thing about that is that's a lot of time on the drivers, the crossovers, the connections. There are no push-on connections. They're all soldered. So there's a good chance when a dealer drives 100 miles to deliver a pair to a customer who bought them and they finally came in, because we always have a backlog, they're going to work because they've got a lot of time on them already. They're not broken in. They need more time, but they've got a lot of time on them. Anything that was improperly manufactured is going to fall out long before it goes through even QC.
And I'm just curious.
That video, by the way, is I got the inspiration to do that video by watching a program, How It's Made. And I said, wow, I watched 5 of those in a row. And that's really interesting. They were making, I think, toothpicks and spindles for chairs. I don't remember anymore, but jelly beans was one of them. And I says, I ought to do that on our loudspeakers. That's where the inspiration came from. And it's on our website, on our YouTube deal.
And if I'm just curious, I've got something going on my computer. I hope everybody can hear me. You know, a crossover, to my inexperienced mind, consists of a coil or a capacitor or 2 or a resistor or 2. What kind of changes might be necessary when your son is going through the process you just talked about, and maybe the crossover needs some kind of adjustment? It's not quite right. What physically would need to change?
Well, you're changing the value of some of the resistors. You're taking turns or adding turns. Well, it doesn't work to add. but you're taking turns off of coils. You'll see that in that video where Nathan is taking some turns off of one of the coils that we wind in-house. And the other thing you're doing is the capacitors. You buy 10% capacitors. That means there's a 10% variance in there. And you'll pick one on the high side or the low side or whatever to make it do. There's a lot of emphasis in the loudspeaker world about the crossover. I really could care less what a crossover does, because what I'm looking at is the microphone. I'm looking at where the listener is. And I'm going to do whatever it takes to that crossover to make the combination of the crossover, the wire that connects it, and the driver that it's driving do what I want it to do at the listening position. When you look at our crossovers, they look complex. It's not really as complex as it looks, because film capacitors, for instance, they're only so big. And if you need 20 microfarads, it takes a lot of them. Well, in a schematic, that could be represented by one capacitor. But on the circuit board, it looks like 10 of them. So they're not as complex as what the photographs appear to be. But there are a lot of Zobel networks and resonant peak filters and everything to make these drivers behave as a resistor, so that the crossover, the coils and the capacitors, will do what you want them to do at the listening position. So we have had some people in Europe one time look at our crossover in one of our models and say, wow, this guy has no clues what he's doing. This doesn't fit any of the models that are in the books. And that's because I really don't care. The crossover has to force the drivers to do what I'm looking for. It's a combination of the driver and the crossover. And we manipulate those to give us what we need at the listening position.
And with a first order crossover, you mentioned earlier, you have to really have seriously good drivers to handle, or I don't know if the handle is the right word, but to go with a first order crossover, you can't just have typical quality drivers. I'm wondering, and one of our members asked, did you have difficulty in your early days finding OEM drivers that would work for your design?
Oh yeah, we basically were not using OEM drivers except for woofers, but mid-ranges and tweeters, we were probably out of the OEM business by the early 80s, 82 or so, because it requires a driver to have good behavior over a lot of octaves, and that was very difficult to find, especially in mid-ranges. So it was mid-range where we put, that's where our initial patents were. It's where I put, the mid-range was the problem. And that's where we basically designed our own drivers, made some of our own cones and so forth first. Woofers and tweeters, not so much. I play with the dome materials on tweeters, but they're conventional tweeters, conventional magnet systems, conventional voice coils. All we do is manufacture the actual dome, in this case out of carbon fiber, and that's sent to the various scan speaker CAS, and they put it into drivers that are stock items for them, but they're using our diaphragms. There's no sense in spending a lot of money reinventing the wheel when their motors are perfectly fine and their structure is totally adequate.
For the mid-range drivers where you're submitting your own requirements and designs, do you ever get pushback from your manufacturer? Like, what are you doing? This is too extreme, or anything like that?
You don't usually get pushback, but the cost for them to develop a new driver and put it into production is so high that you just couldn't get them to do it. And this is why in the mid 80s, I actually tooled up my own baskets for the push-pull woofer that eventually went into the Model 5. We tooled up our own basket for the aerodynamic, the rear wave, the internal diffraction problem that mid-ranges have with all the reflective surfaces behind the cone. We tooled that basket up ourselves. And now with the different cones and domes, we tool them up and we make them in-house and then provide them to these manufacturers. And they're totally willing to do the sub-assemblies to put them together and do the first round of QC. I'm not interested in magnet systems. I'm not interested in having a big magnetizer in the shop. They do that very well. The whole adhesive science is another thing. Even once you find the adhesive, the dispensers that can dispense it accurately and not plug up is a nightmare. That's a whole different ball game, and I don't make enough drivers to be worthwhile investing in all of that, or even becoming an expert at it. They do the job very well. So it's been a good working relationship with these companies. But yeah, they would never do it on their own. This is what forced us to get those critical components that were so unique or different. We just made them ourselves. I designed them and made them.
Okay, cool. We have another question from one of our members, and it reads as follows. There have been a few speakers over the years that have tried to be time and phase correct. For example, the B&W DM6. They seem, though, to have disappeared, leaving only you. Can you comment?
Well, the DM6, it was they had a staggered baffle, if you'll remember, but they still used deep order filters. They were not time and phase correct. I don't know what they were doing with that design. The 801s appear to be aligned. A lot of the B&W products to this day appear to be aligned. But if you look at the stereophile measurements of any one of them, they don't give you that triangle. A time and phase correct speaker, when you put an impulse in, as John Atkinson does very well, will give you that triangle. You'll have a steep leading edge, which is created by the tweeter, and it will fall off at an angle, which simply means that's the part of the square wave that a speaker can reproduce. The reason it tapers here on the right-hand side of the impulse is because the speaker's not flat to DC. Well, no speaker is, so that's what causes the roll-off. So the leading edge is created by the tweeter. That then hands off to the mid-range in this area here, and then it rolls off. And then the woofer comes up, starts at the same point, comes up here, and joins that line and gives you that triangle. That is the definitive way to know whether a speaker truly is time and phase correct. So many speakers look like they are, but never were. The Dahlquist DQ10 had every other driver out of phase. They were a horizontal array, and initially they weren't even mirror image to one another. People did that as modifications later on. But every other driver was out of phase, and it used some first order filters, but mostly second and third order. You had the Spica TC50, which is and was back then. You had the Dunleavy products, Jim Teal, when he was alive. All of his products were time, all of the speakers he made were time and phase correct. Meadowlark, those were, if you look at the measurements of those were time and phase correct. So we may be one of the few left standing, but we're not the only one. Other people have had this same vision. It's just a very difficult and tedious process to make them. It's your reason for being in business is to make money as easily as possible. You're not going to go there.
Okay. Here's a little bit of a question that comes up at some of our meetings, and I don't have a view on it, but whether a speaker's drivers, as you just mentioned, sometimes are out of phase with each other, or sometimes are all in correct positive phase. can either design yield a correct answer, or do you feel that they should all be in positive, correct phase all the time?
Well, if you want, if timing and phase and what that does in the harmonic structure of any instrument and how it adds up as a listening experience, if that happens to be something that's important to you, and it's a learned experience in a way, it's not the most important parameter of a loudspeaker, but once you live with that, once you experience it, it will make everything else sound kind of wrong. That isn't. Okay, now that's not important to everyone. Not everyone has a sense of timing. I remember one time a very good dealer of mine, he's still a dealer of mine, and he has great ears. He can really listen. And he'd got a new turntable in about 35, 40 years ago, and I happened to visit there. And he was so excited about that turntable. And the wow in that thing was so audible to me. I'm on the sustained piano note where the keys are open and you're just gonna, I mean, it was like you're swimming. And I asked him, I said, don't you hear that? And what? Would hear what? Timing is not a focal point for everyone.
Mm.
And I, again, what people expect out of their experience, all these speakers that are not time and phase correct are not necessarily wrong. They're looking and they're looking for a different kind of listener. Their experience, the expected experience, is different than what people who love Vandersteens and end up being very devoted to them. It's the experience and the emotional connection that they want with the music. And they get to that point where if it's not, they'll listen to a Teal and say, hey, it sounds great. A little bright for me, but or they'll listen to a Dunleavy and they'll like them and they'll like Vandersteen, but they'll listen to a lot of other primuses. They just sound wrong. There's something wrong. And that's because they're sensitive to this, but not everybody is. So I'd never be the one to say, hey, we make a speaker that's perfect, which doesn't exist, and everybody else is wrong. That's just not it. It's just that I'm looking for I'm looking for a listener who has the same expectations or similar expectations to me, who wants the experience to be like those instruments actually were there and could have made those sounds. That's I don't know how to put it any other way. I'd be the last person to say that these other designs are wrong. There's a very good reason why every other driver is out of phase, though, when you understand that drivers, very few drivers are pistonic. When a driver starts to go into breakup mode, what happens is a high percentage of the surface of that, let's say cone, turns out of phase on itself. So literally, a positive impulse causes part of that diaphragm to go in the other direction, like it's leaving the scene. Now, when you hand that off to the next driver, let's say it's a mid-range, and let's say it's 600 cycles, that cone is going to be pistonic. It is going to be replicating that positive signal exactly. But you have to hand off to a driver where those frequencies are now leaving the scene. Well, how do you join those two and leave a flat frequency response when part of it is going in the wrong direction? Well, the way you do that is you just reverse the phase of the mid-range. Now the lower part of that mid-range is in phase with the upper part of the woofer already in breakup, and you get a nice flat response. If you were to put that in phase, both drivers in phase, you'd have a huge notch, a cancellation notch, where those two drivers sum. That designer has no choice. That's with the drivers that he selected, if he has, that's the way the crossover has to be. Because if anybody ever measured it and found those great big notches in its response, he'd get ostracized for not knowing what he was doing. and
And
not being.
he won't get ostracized for putting the mid-range out of phase.
Vandersteen supporters would say that wouldn't be the right thing to do, but there's a lot of people that accept it as just fine. That phase doesn't.
I guess I meant in the press or in the reviews.
Yeah. I think you have a different situation there. I mean, can you really, for those of us, that small percentage of us that are so time and phase oriented, would it really do the industry good to say that all these other ones have a fatal flaw? I don't think so, because it's not a fatal flaw. It's only a fatal flaw for people that listen to music the way I do. So, you know, it's that's the only way. Hey, we don't all expect the same experiences from our hi-fi. Look at when you go to one of the most interesting things to go to a show and see the diversity amongst loudspeakers. As we spoke earlier, there's a convergence in the way amplifiers are sounding. You know, tube amps are sounding quick and fast and everything, like, and solid state's not harsh and bright anymore. There's a lot of really good solid state amplifiers. So they're kind of taking on characters that used to be the domain of a tube amp. Tube amps are kind of going where solid state had the only advantage. And cartridges are starting to sound more the same than different from way back in the day. Wires are getting more similar than they were. They're getting more straight wire, more true to the source than, say, 30 years ago. The only area where all bets are off and anything goes is in the loudspeaker, at least to that degree. And that's because without tone controls or any means of manipulating these recordings, people are going to tend to find a speaker that plays the music they like most, the best to their liking. I mean, it's, you know, some people like red wine, some people like white wine, some people like beer. I mean, it's just, it's not a right or wrong thing. It only is for people that have the same expectations or similar that I do.
I want to pick up on a word you just used, the tone control concept, because it reminds me of Vandersteen speakers being one of the very few models that offers tone controls on the back of the speaker. And I understand that in some of your more popular models, those controls, which I believe apply to the tweeter and mid-range, have gone away. And can you talk to us about why that change happened?
Yeah, they're not really tone controls. They were shunt networks, so not really in the signal path. But because they were modest priced, you're talking about Model 1s, Model 2s, Model 3s, which were not expensive state-of-the-art speakers. They tended to go into systems where people couldn't afford or didn't have the ability to do a lot of room treatment, couldn't afford maybe buy the best of equipment or whatever. And it gave them some small amount of adjustment to get the sound right in the listening position in an imperfect environment. And when we came out with the Trio and the Quattro and the 5 and the 7s and the Quinto now, the more expensive, the more advanced products have said, okay, now, you know, this is not a suitable way to fix the problem. You do need to get involved in careful room placement, and some room treatments, acoustic manipulations, and so forth. And the desire for the resolution to be higher was there. We just removed them, by the way, on the new Model 2 Mark III. The 2CE Signature Mark III no longer has a treble and mid-range control on it. Those never were shunt circuits, but the fact that they're not there and other changes that we made did advance the sound of that speaker. Yet another, we don't make a designation change unless there's a significant change in the sound of the product. We don't come out with a Mark II version it's not a marketing thing. Say, hey, we gotta kick this back. Brad come to me and say, hey, this is getting long in the tooth. We need a Mark III version. What can we do? No, when enough new developments pile up that I can put in a product for that amount of money, they just happen. And they don't happen unless we can bring something to the marketplace. The reason we did that is that those controls are expensive, and that money was better put into better sounding capacitors. And you're looking at $15, $20 in cost in a pair. And that doesn't sound like a lot, but you put $20 or $30 more into the capacitor quality, you're going to get a reward for that. And the fact that they're not in the circuit helps. And most people buying Model 2s, because they're not the most attractive things in the world. They're not buying furniture. They're buying performance. And they're now upwards of $3,000 a pair. So expectations are going to be higher, and we needed to up the ante a little bit, and we did.
Gotcha. So you as a company have really focused on succession planning, which is something that many companies really don't focus on. And you've brought members of your family into the business. I was wondering if you could talk to us just a little bit about the ways in which that's worked out for you, and maybe if there have been some challenges associated with that as well.
Well, my wife Enika and I had 4 children, 2 boys and 2 girls, and for whatever reason, I made them earn their own way through school and everything, and I had a business, and they could work there any hours they wanted for reasonable pay while they were working their way to buy a car or to pay the insurance on a car, put gas in it, and go to college and all that. I didn't do that for them, but they could work at Vandersteen Audio, and all 4 of them got into it. And our oldest son, Jeff, he's into all the finish work. He does the automotive finish, and that's his area of responsibility. Nathan helps me with R&D and the anechoic chamber work. Our older daughter, Jacqueline, is the office manager, does a fantastic job in the office. And Katie, our youngest daughter, helps me build our amplifiers and the critical crossovers that go into our bigger product. So it's been a natural. They want to keep it going. I'm way past retirement age. I need something to do. I still love what I do as much today as I did yesterday. And they want to keep going. So we've, and that's great.
Yeah.
I love it.
Have you are the,
keeps all the grandkids close to home too, and that way grandma's happy.
Right. Well, you are the designer. Have there been some of your designs that have excited you, but then for whatever reason, you could not put them into production?
That's happened once. I made a monitor that had an adjustable stand and everything, and showed it at the show a couple of years, was well reviewed by the dealers and everything.
Mm-hmm.
But when I finally added it up with the stand and everything, the price that it had to sell for was, in my opinion, just too high. And I says, well, that's a great speaker, but we can't afford to make it. For that kind of money, they can buy a floor-standing full-range loudspeaker. So I didn't put it into production. But that's really the only example of that. I just didn't think it represented good value to sell a mini monitor for something for a speaker, where at the time they could buy a pair of Model 5s with a powered subwoofer and room EQ, and for close, within $1,000 of the same price. I just said, just doesn't make sense. So I didn't
What
put it
made
in.
that monitor so expensive?
The labor and the fact that the stand was complicated and something that we couldn't do in the factory involved other vendors, and getting those vendors to make the finish we were looking. It was just too many pieces, and that's all expensive. That costs money.
So the stand was part of the issue, and that's interesting. Tell us how important in your mind the stand is for a pair of monitor or bookshelf speakers.
Well, if you're going to do bookshelf speakers or monitors, the stand is an integral part of what that speaker is going to sound like. But I've always had a bit of a different view. In my opinion, bass is the foundation of music. Without bass, you don't have music. And then you have engineering, filter theory 101, first day of school. If you want to do a crossover or add a subwoofer, you basically need 1 octave of overlap. So if you want to do an 80 hertz crossover, let's say, you need good linear response out of this mini monitor down to 40 hertz. Well, that ain't going to happen. That's darn near. So the truth of the matter is, to really add a subwoofer properly, you need to start with a full range loudspeaker. And now this, obviously you can take a small speaker and add a subwoofer to it and get bass in the room. But I'm talking about doing everything in a time coherent way at a high performance level, not just adequate, but at a good level. So I have suffered from the whole idea of the floor space is about the same, and you can get a full range speaker and get bass down into the 30s. I just never really felt it a challenge worth putting that much effort into. Now, we do have the VLR and the VLR-CT. That was different. I was asked, can we have a true bookshelf? And that means not for some audiophile to put it on a stand 3 feet out into the room. I mean, literally have a decent sounding speaker that a guy can or a gal can put in his office and literally put in the bookshelf and have it sound decent, have it be time and phase correct, even though the listening position is not exactly perfect, or you can't adjust for it or whatever. And I said, yeah, we can do that. That's what the VLR is all about. But then again, that's a different solution. I don't recommend that people take that thing, put it on a stand. It needs to be near the boundary. It's back up against the wall. And by the time you add a subwoofer to it and everything, you're better off with a pair of trios. It's going to take the same amount of space in the room and give you much better performance for not that much more money. But people do it. But anyway, how they use the product is their choice. But that's the design philosophy behind it. But it truly will sound great amongst a bunch of books in a lawyer's office or a doctor's office or whatever on a bookshelf. That's what it was designed to do.
That's interesting. I didn't realize that those speakers were not really intended to go on stands. I was looking at
on stands, but we don't make a stand for them. And like I said, how people choose to use them, I'm only the designer telling you what the thought process was. People love them though, and people that have them on stands they found, I assume they're good stands. They must be because they like the sound of them. They put them on stands and they add subwoofers to them, and they love them, which is great.
Yes, it is.
It's not where the design came from.
We have another question from one of our members, and that is with regard to other types of speakers, electrostatics, magnetic planar, line array, etc. Could you comment on those kinds of technologies and how they handle phase and time alignment?
Well, a large line source, I'll start with the line source first. We've never done, there's a lot of things attractive about it. You can move a lot of air. You can be really low distortion because you can line a lot of medium price drivers up in a small, slender column. But the problem with a line source is that its energy dissipates at a different rate through space than low frequencies or point sources do. And the difficulty with them is all line sources become a point source at some frequency. And adjusting the high frequency to base balance in the room and having the reflections of the boundaries of that room be a facsimile of what came directly to you is virtually impossible unless you have a very large room. So we've never made one, and that's the reason why. Too tough to get to work. You're constantly, I made several of them and experimented with it. You're constantly adjusting the woofer level on there, never really feeling like you've got it quite right. And that's because of the different attenuation rates through space in the room by the two different designs. Planar magnetics, it's you know, they move a lot of air. They have the advantage that they don't have any cavity resonances behind them. Our first patent was about getting the reflection-free zone behind the diaphragm. There's as much energy coming off the back of a cone as there is off the front of a cone. And that gets splashed right back into your face, all distorted in time and messed up. So we made an aerodynamic basket and loaded into a transmission line that didn't allow that rear wave to get back and confuse the front wave. Well, planers do that automatically, and electrostats do, and that's one of their beauties. That's the one thing that people like about it, because there's an openness to it. However, time aligning that, if you look at the different distances from your ears from that large panel, it's impossible to get a coherent impulse from that because of the fact that you're dealing with possibly 6-7 inches different the distance that the signal has to pass from all the different areas. It's also a very lightweight diaphragm, that is true, but also in a very weak field. And if you look at some of the energy time curve measurements that have been made on them, waterfall plots, for instance, a waterfall plot is a good indication of how much energy a speaker is storing. Well, stored energy that's released later is the coloration of that speaker. That's what it is, because the signal is no longer there. That the back line at the rear of a waterfall plot is the energy and the frequency response of that speaker. The input then stops, and everything that you see in the foreground is a speaker noise, the character of the noise or the diaphragm, and that's the sound of that diaphragm, because the input is gone. There's no input anymore. If you look at the planers, it's like a sea of chaos. It's kind of like having a little reverb on every note or every little transient. Again, but they are, that because the surface area is large, they are quite low in distortion in a traditional sense. So again, speaker design is juggling of a whole lot of different parameters, and you have to pick what's important to you. And there's something in all of that that I described. I know how they work. I know what they do. There's something in all of that that some people really love, and therefore they buy it. But it was not for me, because there was no way to make it time coherent. Electrostat's very similar. It's, again, a lightweight down, but in a weak field. You still have the difficulty always of eventually having to, in most cases anyway, to practically get any bass in the room, you have to eventually go to a point source or some kind of a subwoofer. And my listening preferences has always been for getting all that energy into the room in as small a space as closely grouped together as possible. so that the reflections of the come from the ceilings, the walls, and everything, when they finally do get back to the ear, they are a facsimile of, in timing and everything, of what came direct.
Say the end of that again. They are a facsimile of.
They're a facsimile of that energy that came, that signal that came from the speaker direct to your ear. All of those reflections coming from the boundaries of the room, which is part of the acoustics of what we hear. You don't want to be in an anechoic chamber. You get sick. So our brain wants to know and wants to have the space we're in defined. That's part of being comfortable. And I want those reflections off of all of those boundaries to be a facsimile or similar to what came direct, not totally different in timing and frequency response and everything. Well, the only way to really accomplish that is you have to put all that energy into the room in a small space. Group those drivers as close together as possible so that all of those relationships can be preserved when hitting off of the boundaries.
Okay,
Not a big thing, but it was to me.
And taking that point, I wanted to ask you about something that's written on your website on your bookshelf speakers. It basically, and I'll screw this up, I'm sure, but it basically says that for the thing to work right, it has to be a concentric tweeter. The tweeter has to be in the center of the woofer. Why won't a bookshelf speaker work right for you, for your purposes, with a tweeter sitting 1 inch above the woofer?
Well, because that would make the alignment of the ear to the tweeter and the woofer very important for alignment. Not everybody can put a bookshelf to where that alignment is right. So the whole idea, a coax is a compromise in, we believe, in minimum baffles. Now we have a baffle around our tweeter that's moving to boot. Not what you would prefer to do for in an ideal situation. But if you want it to be time and phase correct, where you have to put them where they have to be, and you can't align them, like adjust a tilt on a pair of trios. You know how high your ears are when you're sitting there. You adjust the tilt, all's good. Tweeter, mid-range, and woofer. You can do that. But if you want a speaker where, like an on-wall for video purposes, where you're putting it on the rear walls, who knows where, at whatever height, yet you want that information to be time and phase correct, it's got to come from a coax. Compromises be damned. The biggest compromise then would be in timing. So that's why I've made the choice. Same with the bookshelf. As a designer, I never know where they're going to be relative to the listener's ears, and there's going to be nothing we can do about it, except to make it coincident.
Now, the bookshelf speaker is going to be up on a bookshelf as you intend it to be used, and that's going to be 12 feet away from the listener.
Yep.
Is it really that critical that you've got to move that tweeter? It can't just be right next to the woofer. It's just not going to work.
If you want that impulse to add up in both time and amplitude, if you want it to measure the same, you want to take a question, Brad. Brad, our marketing guy and salesperson, is here. I need to take a break for about 2 minutes to go to the bathroom. Maybe you have a question for Brad.
Sure. Brad, tell us what you do first so we know.
Hey, hello everyone. So yeah, I've been with Richard about 3 years now, and I'm working with dealers and training and spreading the gospel, so to speak, of the Vandersteen legacy. And I'm about 33 years now in the business, and I've worked with various companies over that time, and really feel privileged to be in this position to help people understand Vandersteen better.
Well, I have the perfect question for you. It came in from one of our members, and that is, how do you feel about reviewers? Are there reviewers who seem to really get what you're trying to do at Vandersteen, and others who seem to not quite get it?
Yes, I think like in any interest that you have, there are experts, and you have to kind of get to know what those experts say and how they listen and what kind of music they like in order for them to be your expert. You know, whether it be a movie critic that likes movies like you like, that happens within the audio world for sure. And, you know, somebody who is, like Richard has talked about, sensitive to time and phase correctness is very important to us, but not all the reviewers are that way, for sure. And,
Yeah.
you know, you just got to have the right combination of someone who has interest in the product, and they'll express that interest to us at a show or something after hearing the product, or at a dealer, and say, wow, this really sounds fascinating. I would like to you know, learn more about it. And it kind of just starts there, and you fill it out and make sure that you've got someone who's at least sensitive to what we do.
If you did get a bad review, would you want to be able to respond and kind of put forth your counter view, or would you want to just give that review as little energy as possible and let it flow down the river?
It's a bit of both. If there's an educational point to be made about the product that didn't come across properly, absolutely a response, I think, is in order. If the reviewer, which hasn't happened much, but if a reviewer just doesn't like the product, then, you know, you got to just let them have their opinion. I mean, we've been around 45 years now, so it's we have plenty of precedent that it's okay. The speakers are good. So I'll let the main star get back here. He's back.
Here's a question from one of our members that I'm not sure I completely understand, but it is talking about different levels of frequencies and phase coherence as you look at different segments of the frequency spectrum. And the bottom line question is it true that handling phase over the 10 octaves is easier at low frequencies, but becomes more and more serious and critical as frequency rises?
I don't know the context of the question, but I will say, if you look at amplitude and phase together to replicate this waveform that an instrument that was captured in a recording, and now we're trying to put that pressure wave into a room. You said you're a drummer. When people comment on a speaker's performance in the bass, oh, that's tight and defined, that's really good. That definition of that bass is in the mid-range. If you listen to a woofer all by itself at 80, 100 hertz, it sounds like a bunch of blubber, okay? Without the leading edge being attached correctly to that low frequency waveform, without that connection being, it's just not going to a drummer who's sitting there and knows exactly what it sounds like. It's not going to sound aligned. It's not going to. So I think it's as important in the low frequencies as it is in the high frequencies, because you're trying to recreate, using 3 or 4 drivers, this waveform. Unless I've missed the context of the question, I think they're equally important. I think it's easier to do in the bass, for sure, because the wavelengths are longer. Where you put a subwoofer in a room with a good sounding, with a time and phase correct loudspeaker is not near as critical as it is where I put the woofer inside in a, let's say, a trio. Obviously, because that woofer goes up to the crossover point of 800 hertz. So it's not near as critical at 32, the low end response of a trio, but it gets even more critical as you hand over to the mid-range. That's very critical. So maybe that's what he meant. It's easier to do in the bass. Subwoofer location where you're rolling off at 80 hertz is not as critical because the wavelengths are long.
Yes, and that was actually part of his question, which I didn't read, but great. That sounds like you're on the same page. Whether we're looking at the last year or 2 years or 5, I wondered if you could tell us what's the most exciting innovation or development in your company to you personally, whether it's a new color scheme, whether it's a new voice coil design. I mean, what's gotten your engine revving over the last few years the most?
Oh, that's hand down the carbon balsa diaphragms. There's nothing like it on Earth. It's very, very low distortion. An ideal diaphragm would be infinitely rigid at all frequencies with no ringing, because ringing, that noise that comes off of something after the impulse has stopped, that has a character that interferes with our music. Steep filters have ringing. It causes notes to hang on and be harsher and harder than they need to be, unnaturally so, in my opinion. Having this truss effect of the carbon fiber skins with the balsa in between, like the webs in the trusses on your roof, to get the stiffness you need, but yet keep it light enough in weight to have a reasonable amount of sensitivity. Because we can only go so far with a diaphragm. A mid-range needs to be about 3.5 inches in diameter. If you make it bigger than that, then some of those frequencies trip over themselves within the cone. So, 3.5 inches, we call it a 4.5, but the actual radiation is 3.5 inches. So, and the carbon tweeters, having a material that is that stiff, but yet has such good internal dampening to where the ring pattern is almost unmeasurable, is by far musically, from a design standpoint and also musically, the high point in my 45 years.
So let me try to make sure I understand. So looking at the mid-range, you're talking about the sandwich: carbon fiber, balsa wood, carbon fiber.
Right.
And what might seem to be the ideal material for a mid-range driver might be metal, because it's very, very rigid. But you're saying the problem with that is it's going to have ringing effects.
There are metal, there's ceramics, which is basically hard anodized aluminum. There are all different kinds of aluminum cones, and they are stiff and they can be pistonic. But if you want to use first order filters, when they break up, it's a big, nasty 15 to 20 dB peak, which is the sound of that material. And you have to get rid of that in the crossover. That forces you to use steep filters.
Like a fourth order.
Third or fourth order. Yeah. That means you can't be time and phase correct. So end of story for me.
So that's the problem with a third or fourth order crossover for you, is that it's making time and phase correctness impossible.
Correct. So if you are able to use steep filters, there are the ceramic drivers out of Germany, Accutons. There are a lot of aluminum drivers, there are really a lot of drivers that are pistonic to a pretty good frequency. The only problem is in the where we need to have good linear response in order to slowly hand off to the next driver, they got this big old nasty peak in there that I can't, that is terribly audible and amusical. and I can't use the steep filter to get rid of it. So it basically means it won't work for me. And that's what's so demanding on our drivers, is when they do begin to roll off, when they do go into their breakup modes, they need to be very well damped. In the case of our carbon fiber balsa cone, that breakup mode happens at about 9K. We cross over at about 45, but it's only 4 dB high instead of 20. So that's because the balsa is such a good natural dampening material. Later on, I find out that GM puts it in the floorboards of the Corvettes. It's carbon fiber with balsa in between. They're not worried about the strength. They're not that worried about depth, weight, or strength. They were trying to block road noise from coming up through the floor and making the car a more quieter, more pleasant experience.
Wow.
Yeah, which I didn't know that until after the fact, but balsa is incredibly light and stiff in compressive strength, but it's also an amazing damping agent. So it damps that carbon. What little bit of sound carbon fiber has, it takes it away.
Why do you need anything more than the balsa, which sounds like it's meeting all the requirements perfectly for the driver to be making you happy?
It's strong in compressive strength. So if you go outside in your garage, assuming it's not sheetrock, and you look at what's holding up that roof as a 2x4 at the top and a 2x4 at the bottom, and it's holding a hell of a snow load, where you guys are sometimes, and you go, how can that be? I could sit on a 2x4 and break it in half because I weigh 300 and some pounds. Well, the reason it can hold all that snow is it's got these little webs in it. It's called a truss. Those little webs are the purpose of the balsa. That was the initial purpose. A very lightweight way of putting webs between two surfaces that are at a distance apart to get maximum stiffness without adding much weight. The side advantage was it also does a great job of damping it.
But you couldn't use
balsa in itself is strong as you compress it, but you could snap it off easy if you tried to make a cone out of it. It's only strong in one dimension.
I see.
The driver needs to be strong in 3 dimensions.
So the carbon fiber is for the overall strength in different dimensions.
That's correct. The purpose of the balsa is only the webs and the truss.
We've got more questions coming in than I think we have time for.
Well, let's try to rapid fire some of them.
I wish there were some that could be rapid fire. What you just said about the driver that you've developed is really exciting to me.
Me too.
Would you ever consider licensing that to other companies?
No. Been asked. I've been asked.
It sounds pretty sexy. I don't know.
Nobody. You're looking at a mid-range cone, or the cone alone is $1,700. Nobody wants to pay that kind of money for a cone. They're used to buying a $5 cone.
Wow, $1,700?
Yeah.
Of pure cost.
They're looking. If you're looking at a $30,000 pair of loudspeakers, they want to buy all the drivers and the cabinet materials for $1,700.
Okay. So you don't think the demand?
It's passion.
You don't think the demand would be there even if you were willing to license it?
No, we're not going to find out.
Fair enough. Can you tell us why you chose to produce your own amplifiers for your powered speakers and subwoofers?
All of our bigger products have powered subwoofers because it's the only way to give effective room EQ for solving room problems and great bass in a smallish enclosure, because you have to rely on equalization. The ability for an engineer to know the box, to know the driver, and design an amplifier and pre-distort or use feed forward and make the three of them work perfectly, or as near perfect as possible, and be able to put room EQ in it without tampering with the main signal going to the tweeter, mid-range, and woofer of this person's treasured $100,000 preamp and $100,000 power amp, has always been for me the only way to make a loudspeaker, because everybody has bass problems, and I just, it's also 90% of our grief because of all the technical questions, and it makes the product look like it's complicated. So it's hurt us from a marketing standpoint.
Wait, I'm sorry. I'm sorry, Richard. It's 90% of our. I didn't hear that.
Of our headaches and grief, because it makes the product look excessively complex. It's not, and it's hurt us. It hurts sales, and it involves a lot of technical support that I can fully understand people not wanting to get involved with. But
How does it hurt sales?
Pardon me? Well, because it seems overly complex, and for a lot of people, they feel like they'll never get it right, so they buy something similar. We run into this every day, every day. So the neat thing about that, when you look at amplifier design, and don't forget my background is actually in electronics, there's a lot of things you do to an amplifier in order to control the back EMF and the massiveness and the current demands of a woofer. You have to parallel up a lot of tubes. You have to parallel up a lot of power devices in order to deal with that back EMF, in order to be able to control who knows whose woofer, and it might only be 1 ohm. Well, all of that is a form of time distortion, because you can't get all of those devices to really act as one. You need emitter resistors, which has its own problems. So I said, well, this isn't a market for anybody in the amplifier world, because not very many people make these high pass things. But why not design an amplifier, put the high pass in there, and design it to be for basically a powered speaker? The problem with powered speakers is they've been a marketing disadvantage in the United States forever. People don't tend to put that much of the control of their sound in one person's hands. They want to mix their preamps and power amps and their wires and their speakers. They want to put, it's like they're the chef and they're putting their 7-course meal together their own way. So what I've done here is created a more ideal powered speaker, but yet leave everybody the choice. You don't have to buy it. But if you want to hear what we intended the product to do, that's the best way to get it.
Tell us.
Because there's a lot of advantages. You don't need forward feedback. You don't need to worry about big woofers. You don't need to worry about high current demand. There's only 5 parts in the signal path, because there's a lot we don't have to worry about. It's big time cheating. It's not that our design is that innovative or anything. We cheat a lot. We don't have to worry about woofers. And, you know, every designer is going to know how much not having to deal with woofers helps your power supply, helps your output stage, and on and on and on. It's just this little world. And that's exactly what I'd do if I made a power speaker to be more ideal. But I just put it in a separate box where people have a choice, or they can do it incrementally.
And what about that amplifier? What's the design choice that is it class A, B? How do you?
Well, it's unique in that it's a quasi kind of cyclotron done solid state, where you have 2 single-ended amplifier chains, one for the positive part of the waveform, one for the negative waveform here and here, and the two are connected together with the speaker load. It's quite unconventional, been done with tube amps. It's not a very common circuit, but it does allow you to use all N channels. Most amplifiers require complementary pairs N and P channel, either FETs or bipolars. And if you look at their specifications, they're no more complementary than the man in the moon. So this is a circuit that allows you to use all N channels. And in the liquid cooled amps case for the Model 7 System 9, it uses tubes for the input stage. The first driver is a 6H30 tube, and then it goes solid state. And that's 600 watts into 4 ohms, 300 watts into 8 ohms. And then the baby version is the same exact circuit, but it's all solid state, and it's 150 watts into 8 ohms and 300 watts into 4 ohms.
That's
But again,
really,
if you try to drive a speaker with big woofers, it's not going to blow the amp up. It's just going to go. There's a little push button on the front of it. When you plug it into the wall and turn it on, it goes into standby mode, which is a green LED. And then you push the button to play music, or you use your impulse through a trigger on the rear of the amp and make it go into operate. And if you hook it up to a low impedance full range a speaker with a real low impedance big woofer in it, and you hit the first bass note, it's simply going to go from blue to green and say no thank you. and that means it's not compatible. It ain't going to work. And that happens with most speakers like that. There are people who are buying them and using non-Vandersteens, because any one of our subwoofers will bring the bass back, being it's a high pass amp, and so you can drive any speaker you want as long as that the load doesn't cause problems.
yeah, I think it's actually a pretty cool selling point for Vandersteen that you're putting so much thought into the amplifier. You know, I expect a speaker manufacturer to basically throw in a Class D amplifier.
Class D, I can't go there. I worked so hard to try to get Class D to work for our subwoofer amplifiers, and I just could not get satisfactory performance for me. So we ended up with a digital power factor corrected power supply, but it's still a linear, all NPN, quasi-complementary bridged amplifier, no feedback. I mean, with high amounts of feedback in all of our subwoofers. Because to do bass right, you need a lot of feedback. To do mids and highs right, it's better to not have feedback, and there's less need for it anyway. You put the two together the way we did. Make a high pass amp with no feedback and put the high feedback in the solid state. We had a customer that had some $100,000+ amplifiers, and he wanted a pair of 7s, but he didn't want to buy the 7s because they had this cheap plate amp in. And the dealer asked me, what do I do? What do I do? And I said, well, I don't know. Tell him that it's not a cheap plate amp, first of all, and it's dedicated to that woofer and that enclosure, and that's how it works. And the dealer got back to me a week later and said, no, he's not buying it. He doesn't like the idea that his $150,000 amplifier is only going to be driving the upper end. And I says, well, I'll tell you what you do then. So I instructed him how to wire it up, remove that cheap, quote, plate amplifier, and hook it up to his $150,000 amplifier. Monday morning, I get a call from the customer. Is my $150,000 amplifier really that shitty? Because it sounded so bad, I guess, when he hooked it direct. And I said, no, it's a great amplifier. It just wasn't designed as expertly for the task. It's an unfair comparison. So that finally got the point across that when a designer has the woofer, the amplifier, and the enclosure, and has that all perfectly defined, even the hookup wire, you can't beat that. Done properly, there's no competing with it.
Right. I think we're all jaded here in the consumer part of the industry, and we are jaded such that we don't trust that there's going to be a really great speaker company that also really gets the amplification to a T.
Well, you know where everyone's trust ought to be? It's not in a review. It's not in what Richard Vandersteen says. It's right here. It's right here.
And your customer proved that.
Exactly. And if that doesn't convince them, then they need to listen more. Because before you part with your hard-earned bucks, all of those blanks need to be checked off. You know, it needs to deliver.
Well, at this point, I've really overstayed our welcome. This is now officially the longest interview we've ever done for our members in the Philadelphia area audience.
Really quick.
And I want to just conclude with a question about the state of the industry and your perspective on it. Whether it's speakers, whether it's sources, whether it's the music itself, where do you see us heading right now? And where do you see us in the next 5 or 10 years in terms of the way audiophiles are interacting with the music they listen to?
Well, I think there's a lot of changes on how music comes into our homes. I believe the highest resolution source still available to us today is the old vinyl record. It's an incredibly crude system, but it's amazing how much information is there. And it's a time and phase correct. It doesn't involve a lot of phasing. There are some time constants involved because of the phono RIAA, but basically it's a crude system, yes, but it's also very simple. And lots of these things to do with nature are preserved better than they would be trying to. And it's trying to, but digital has gotten better and it's delivered to us in very convenient ways. And the important part of it all is music, and it's bringing music to more people. And specialty anything has always been defined by the fact that few people care. That's no different in audio, no different in wine, no different in cars, cameras, you name it. Few people care to push the envelope to the extent that we audiophiles push our hi-fi systems. For most people, a much simpler system is totally adequate, and they look at us as being nuts for investing what we do, not only in money, but also in time and emotion and everything into what we do. And I think that's great. And I think that is going to continue. As the pyramid gets bigger and bigger because of music being more and more available, that little tiny part on the top that represents high-end audio is going to continue to grow. Some people say that they think high-end audio is shrinking. I don't believe that. I haven't seen it in 40 years. There was a period of time, maybe a decade ago or so, where in certain parts of the world it became socially hip to have a hi-fi, an expensive hi-fi, even though they had no interest in it, even though they weren't really, quote, audiophiles. And it caused the industry to get kind of a false bump where there was a lot more of this stuff consumed that could really be supported by the passion. And so there has been some shrinkage for some people because that's gone away. That fad is no longer with us. Here domestically in the US, it's still not socially acceptable for a very affluent person to have a nice pair of freestanding loudspeakers in their living room. It's okay to have a 9-foot Steinway, or you can have all the art in that room you want. You can even have, like we have here, a regulation pool table. But a pair of speakers, not so much. First thing the designers do is tell their owners, well, if you want me to do this job for you, those speakers are going to have to go. We need to go to something in wall. And in a way, that's a shame, but people, that's just a fact. Definition of specialty is few people care. I think we're going to see more advancements in materials and application of those materials. My goal has been take what I know and bring it down into the lower price points. Take those materials, find more cost-effective ways to produce them and use them, and refine the products so that it doesn't have to be so expensive.
Great.
Yeah.
That was going to be one of my questions, actually, is are you looking to take some of your advancements and bring them down into your more affordable models?
Oh, we have already a lot. I mean, you take all the technology that we put into the Model 7, that was 10 years of my life. Well, now that some of that technology is available all the way down into the little VLR CT. And we have the Trio CT. All of that came from, and of course, the new Quinto has the Balsa mid-range of the Model 7s, and the carbon tweeter, and the Quattro. We don't make the regular versions. For a while in the Trios, we made both versions, and there was a $1,500 difference between them. And in 2 years' time, we sold one pair. Everybody just moved up to the carbon tweeter because it was that big of an advancement. So we have been trickling it down, and I just want to do more of that.
So I promised that would be the last question, but of course I'm a stinking liar. So I'm going to ask you one more. What kind of speaker cable should we all get?
Well, this is not a cagey answer. Some people might think it is. We always design with a wire that is as neutral as we know how to be. I had to determine what I was going to put for a pigtail on our high passes, because this is going into who knows whose system. Our products, some of them require high passes. So what I did is I made myself a straight wire bypass box. It's a couple of switches, and you go from nothing to a meter of this. And then using the panel and myself, we selected a wire that made the least amount of change in tonality, in all ways, transparency, information, everything. And there are a group of wires that fit in that category. But then there's another group of wires that, and I tried about 18 wires at that time, maybe more, over a course of a year. The one thing that amazed me about those wires is how significantly different some of those wires sounded to no wire. Call it color, call it whatever you want. And this is how people take their systems and dial them into their own taste by how they select. Once they get their system assembled, and this is what I recommend, assemble your system, build your dream, and then wire it up after the fact and make every one of those moves. Move that sound in the direction that you want it to go in your room. So it's no secret that we are very fond, I personally am very fond of the AudioQuest cable, but it goes beyond that. It's more solid conductors, not stranded, and very high quality dielectric materials, Teflon or whatever. And I do believe it's one of the more neutral, the least amount of color in a wire available. But you got to remember, a lot of people are selecting a wire in their systems deliberately for its color. And that's a valid viewpoint. that's as valid a choice as picking from all the different loudspeakers that are out there. Never forget the fact that you're designing a system. It all has to work together. That system is only going to be as strong as the weakest link in the chain. So that's my answer to that. And it's as honest I can be about it. If you're in a situation where you have a room with no acoustic problems and you play a lot of really great recordings and you have the same interest in realism that I have, and tonal colors and everything, you might end up with an AQ wire. But if you have a room, years ago, I got to tell you this story. There was a wire that if you use it with the Vandersteen, it would bore you to death. The wire was deliberately designed to tame bright tweeters. And a man called me and said he had a pair of our Model 4s at the time, which used to be a big speaker we made. And but it was our flagship at the time. And he was using this wire. And I said to him, boy, that would not be my choice. Now, I'm not in the wire business. There was no way I was going to make a buck on those stupid words I uttered. But I did. I disparaged his selection, and I said, that wouldn't have been my choice. Not long after that, Stereophile had a show in that town. And that man invited me to his home. And first of all, it was a castle. That room was like 3 stories tall. There was a tracker organ in the corner of that room. The whole end of the room was all glass with an unbelievable view. And here, ruining that view, is a pair of these ugly-looking Vandersteen Model 4s. The floors were all marble. Even the furniture was that chrome and leather stuff. And then it dawned on me, oh, that's why you're running the wire you're running, because that was such a reverberant, bright environment. He had exactly the right wire. I learned a lot from that 30 years ago, maybe 35 years ago. So it's a way to dial in the system. And I don't think there is an absolute, but there is for every system. Part of that system is the person that's listening to it. He's part of that system, or she. And that's how I'd make the choice.
Well, I think we saved the best for last. That was a really cool answer. I want to thank you, Richard, for spending so much time with us today and for agreeing to share your thoughts. If anybody in the group is interested in buying a pair of Vandersteen speakers, there's plenty of dealers. I know our moderator assisting here, Aaron, is the owner of a store called Now Listen Here, and I believe they carry Vandersteen speakers.
Yeah. Soon.
I guess that's something in the works. My marketing guy, sales guy, just told me.
Good. So that's an easy way for anybody. You can just call Aaron. And so thank you so much, Richard, again for being with us today. And we hope to be able to talk with you again soon in the future.
It's been my pleasure. I enjoy these things. I enjoy them a lot more when we can do it one-on-one in person. I hope those days come back again because I've done these for 40 years. I love them. They are so much fun. I've learned so much from the questions. You learn a lot when you hear what people have on their mind. It's had a big impact on what Vandersteen audio is today. And I hope we can get back to it. We do have an Ask Richard section on our website. Anybody have any other questions? And we also have a Vandersteen forum on our website now, at vandersteen.com, where all the Vandersteen owners can get together and share experiences and so forth. So yeah, one way or the other, I'm here.
That's really cool. And I wish that we could have worked it technologically so that we had input from all the different people watching today, from the New York Audiophile Society, the New Jersey Audio Society, the Audio Syndrome, and the Connecticut Audio Society, as well as the Philadelphia Area Audio Group, our club. But I know that we're all grateful to you for coming together today and spending time with us, and just want to say thanks again.
And thank you, and thanks again for these clubs all across the country that that we're all united in this one thing, reproducing music, and I appreciate it. It's all part of what's important. So, thank you.